Hello everyone. Today we'll be going through a open pit mining project which we have done in the space of supply chain analytics. This is our Capstone project which is submitted by a team of three. In the agenda we have classified into five different steps. That is, the problem statement has been stated, and the objective of this project is stated, and the key insights which we have got from the analytics has been presented, and the suggestions to this stakeholders has been clearly represented, and the data source which we have used is stated, and the data methodology which we have used to solve this problem has been addressed. When we go, basically the problem is that the open pit mining is facing a issue of inefficient production. Even though if there is no any demand rise, also in the basic demand also they are not able to achieve the target. So we have to analyze why there is an inefficient production, considering the present available equipments, why there is an inefficient production. So the basic objective is to build the live monitoring system to understand the inefficient production. So that for that we have built the different dashboards which we'll be going through in the coming up slides. So the basic key insight which we have got from the analysis is that for the overall equipment efficiencies effectiveness, in as you can see in the availability, quality and the performance, if you consider of the three different sectors of this truck, oxymobile and the loaders, you can see this these trucks are having high availability, high quality and high performance compared to the other two. So basically if we see when we again saw the maintenance which are under maintenance, this truck call sector is having a very less maintenance compared to the other two. This oxymobile is having a high maintenance compared to the loaders. So the from this we can state that these trucks and loader trucks have majorly have less downtime compared to the others. So these trucks are continuously available in the ground, so there is no any major issue with the trucks. So when we come into the equipment level production, when we see into the loader section, because there was we found an issue in the loader section. We saw that in the loader class, under loader section there are loader classes and the shovel classes. In that, shovel classes are having a high, they are highly effective in transferring the payloads. That is, they are transferring maximum amount of the ores. So shovel is better than the loaders. So when we go into the top performing and the low performing equipments, in the top performing equipments, we have breakdown into four different sections. That is mileage, its payload carrying capacity, its maintenance, its loading efficiency. If you come to the mileage, basically it is for trucks which is used for the production. These are the particular names which are having the higher mileage compared to the others, which can be considered for the cost effectiveness. And the payloads, if we when we see in the truck section, these names are having a very high payloading carrying capacity, and in the loader sections these are the high payload carrying capacities. If we consider the maintenance, which are having a very low maintenance compared to the other particular category names which are having higher maintenance. And if we come to the loading efficiency, in the loader class, loader section, this loader class is having comparatively somewhat high loading efficiencies compared to the shovel, but shovels are in the very high number also. In third we have a shovel classes also. So particularly these names will are having a very high loading efficiency which can be considered. Subsequently, if we consider the low performing, these are the low performing equipments which are having low mileages, which are having high maintenance. These are low performing equipments. If we come into the quality and the availability of the equipments, Overall availability of the equipments during this process and its quality can be identified by this class wise. So to in order to reduce the time and also reduce the financial losses due to equipments. So basically this availability, if you consider these trucks are having very high availability in the loader section, which are having very high availability, in the auxiliary which are having the very high availability compared to the very low availability equipments which can be ignored. And if you consider the quality of the equipments also, we have separately stated that these are the equipments which are having the good quality equipments which can reduce the downtime also, and which can increase the production. So basically, we have some suggestions to our stakeholders after the analysis, which was brief analysis, which was done in order to increase the production, which was hampering due to the equipments. Trucks with the lesser downtime, high payload capacity, mileage should be preferred over considering its fuel cost. And we should increase the number of loaders to reduce the loading and the waiting time, because uh, basically the trucks are very high level available on the ground, as we can see in the graphs. But this loaders has to be increased in order to sufficiently supply the ores to the trucks in order to increase the production. Equipment that are very less productive should be replaced with the more productive ones in their respective classes. In the same classes, there are some equipments which are having high productivity, so those two should be given a high priority than these low productive equipments. Lesser quality equipments has to be replaced in order to decrease the downtime. Then the frequent the and we have a two brilliant ideas to increase the production. That is the major issue. What we saw is the maintenance issue. So a maintenance checklist has to be prepared basically for these loaders and all, which are having very high maintenance time. Basically, if you consider a week, there should be a cycle where these equipments one equipment can be spared at a time, and the frequent maintenance check has to be done in order to avoid the major breakdowns, so that the availability of machines will be very more compared to the sudden breakdowns, which will be a major ones. So in the if we do a frequent checks of the machines and we find a smaller issues, it can be rectified very quickly, and we can increase the effectiveness. And the proper loaders and the transportation trucks to be identified, as from the data we have given particular names which are having the high availability, high quality, high performance equipments, which has to be considered compared to the other ones, uh, in order to increase the production and as well as to decrease the cost impact. So as we can see, we have considered the three data which was given: cycle data, delay data, and location data. With that, appendix was given. And in and how we have solved is address this issue is that we have analyzed the raw data in the SQL. That is, we have cleaned the data, we have created the tables, everything in SQL. Then we have taken those data, exported those data, and then we have analyzed and visualized using Tabula, using various parameters. And using those parameters, we have created the dashboards which were required to in order to analyze the equipment efficiencies. Basically, five dashboards were created, which you saw. And if you want the complete analysis, file is separately available for all the more informations. Thank you.